We are now live. Hello, hello. Can you hear me? Hello, hello. Okay. I'm not sure what shade of blue that is, Caleb. Yes? Yes, Mac? Hello, testing, testing, 1, 2, 3. Hello? So I think I found the screen that you guys are seeing right now. Looks more like that. Okay. Okay, so okay, I have Caleb's and others' voices now. Okay, I think we're good here. Okay, so I think we should go ahead and get started. Any questions before we begin? Anybody still having technical problems? It is and it isn't. So you can't install Firewall D without systemd because Firewall D has a dependency of systemd. But it isn't. But it is not strictly a. Okay. Hello again? Okay. Okay. Really? I was not aware that you could do that. All of the documentation that I had read had suggested that it was strongly related to the systemd project because of dbus and yeah. And it also has a pretty heavy dependency on network manager, but we can get to that when we get to it. Yeah. Okay. Yeah, I'm just a really lousy municipal internet. That said, here we go. So, thou shall not pass. An introduction to IPTables, Firewall D, and PF brought to you by Clemson ACM. So I'm Robert, and here we go. So coming up, what is a firewall? How do I secure it? How are they different? We're going to be looking at 3 different firewalls today. IPTables, look at some sample configurations. Now, what you may or may not have noticed looking through the slides ahead of time is I tried to make the most similar configurations for the firewall for each of the 3 different firewalls. So what I have written for IPTables is roughly equivalent to what I have for Firewall D and is roughly equivalent to what I have for PF. There are some specific features for each firewall that I obviously couldn't replicate, but I did my best. So what is a firewall? How do I secure it? It's pretty much just a set of rules that control traffic. It allows you to allow certain connection. You either have default block policies or default accept policies. Default block policies, you block everything except for what you explicitly allow, where you whitelist traffic coming in, and default deny, or you also have blacklists where you let everything in except for very specific things. So some general rules of thumb: it is much easier to whitelist specific traffic that you want coming in than it is to blacklist everything in the world that's bad. So use a default reject policy. Also, you want to only open up the required ports. Any additional ports that you open up can and will be used against you. So if you're not using it, block it. If you have console access to a system, like during a competition, doesn't make a lot of sense to have SSH running unless it's a contest scoring requirement. Additionally, if you're not explicitly using or not required to use IPv6, it's better off just to block it. I know that IPv6 is not in and of itself inherently evil, but a lot of software hasn't made all of the patches that they make to IPv4 to their IPv6 branches. So some things, like for example, the BSD kernel had a bug that has since been patched, but whenever you sent certain packets to it over IPv6, you could actually do a stack injection on it. So that would allow you to gain administrative access on the machine that you are hacking into. The other thing you want to do is make sure to log unusual traffic. There's one other thing with firewalls that we're not talking about today, which is forwarding. That will be saved for a later presentation. So any questions at this point? Okay. So let's take a look at how they're different. IPTables is pretty much the legacy firewall for Linux. It's very simple, but it's also very powerful. It runs right on top of the NetFilter kernel module, which is what the Linux kernel actually uses to modulate and control all of the traffic. It's pretty simple to use, and it's very powerful. The one thing I would say is its syntax is fairly archaic. It has a fairly apparently random set of flags that you have to use in order to get things to work. And for the most part, there's no particular rhyme or reason as to why those flags are what they are. The other thing that you would want to note about IPTables is that it's based off the concept of chains. So these chains, think of them as a list of rules that you're going to match. And as soon as you match the first rule in the list, you're going to do whatever that rule says. So if your first rule is allow SSH, your second rule is allow FTP, and then your third rule is block all traffic from 127.0.0.1, you would be blocking, you would not be allowing SSH or FTP traffic to get to 1.0, or you would be allowing FTP and SSH access to 1.0 or 1.7.0.0.1. There we go. Yeah. Okay, someone has the stream feeding back on their mic. So whoever's doing that, if they could mute that, please. Thank you. It gives you very fine control. You can even do things like, for example, blocking TCP header packets that have certain bit masks. It's really kind of obnoxious, all the different things that you can do with IPTables. So if you need a very fine level of control, IPTables is probably what you need to use. Some important files for IPTables. If you're on Red Hat-based systems, it's going to be in etc sysconfig IPTables. If you're on other Linux distributions that are Debian-based or whatever, you may find it's going to be directly in etc IPTables. One other file I want to point out at this point is the file called etc services. So etc services has a list of port mappings and names. So your computer will use these name informations along with the according files to allow you to refer to, for example, SSH by port 22 instead of referring to it as SSH instead of port 22. So these are two very important files to kind of have and know about what they do with regards to IP tables. Likewise, there are some important commands that you'll want to know about. The IP tables command is the root command that all of the IP tables modification commands come from. You can actually modify the firewall while it's running, and you do that via the IP tables command. On older systems, you use the service command in conjunction with IP tables to start, stop it, check its status, so on and so forth. On newer systems, though, you're going to be using systemcdl in order to do the same things. The only real difference is one, you're using you're going to be using the IP table command in the second argument, and one you're going to be using it in the third. One other thing that I want to point out here is there are two commands, IPTables save and IPTables restore. These will condensed, not intended to be modified syntax that will refer to the state of the firewall. One reason why you would be using this is store configuration of the Okay. So do we have any questions on IP tables before we continue on to Firewall D? Okay. Okay. So Firewall D, as Foster pointed out, it may not be strictly part of the systemd project, but for all practical intents and purposes, you are never going to use Firewall D without using systemd also. It provides an ease of use layer on top of IP tables, and it puts the focus on what are called zones and services. So zones are basically areas in which you're going to have traffic coming in and out. For example, you may have an public-facing zone of your network and a internal zone of your network, and you attach routing rules or services to those zones, and then you assign those zones to particular interfaces. So one other special feature of Firewall D is it has the ability to limit what applications can change the firewall. So for example, let's say you have something like a Docker daemon that needs to be able to access the firewall and change what can be done to it. That's exactly what firewall D will let you do. And it will also let you specify and whitelist certain applications to be able to do certain things. So you don't have, for example, your bash terminal randomly opening up random ports. That's one benefit that you have with firewall D. It also has a significantly, in my opinion, clearer syntax than what you would have in an equivalent IPTables configuration. Some important directories that I want to point out are userlib firewall D and etc firewall D. Userlib firewall D contains the definitions of the services. So if you're writing a package or if you're creating a new firewall service rule for a program that you're going to be running on your system, you need to put it in the userlib firewall D services directory. If you are overwriting a previously existing service, like for example, you want to prevent SSH from being accessed on certain, you want to change SSH's default port to 10, you would put that in a etc firewall D services SSH.xml file. So some important commands, there's really only two for firewall D. One is the firewall command and the systemcdl command that you're going to be using. Again, you're probably never going to use firewall systemd. Any questions on firewall D before we move on? Going once? Okay. So here's the one you probably have never heard of before. PF, it's BSD's it's been used in enterprise for ages, especially as a result of NetBSD, which is a very popular choice for firewalls. And also you may have heard of pfSense firewall. So it is really good at forwarding, the one thing that we're not really going to be talking about much this week. But it is very good at handling situations like that. It's also very good at handling when you have large file transfers, because it allows you to move your file transfers into the kernel and have it all handled in kernel space, as opposed to because of the BSD send file system command. So PF is very good at routing things. One other big change between PF and some of the other firewalls is there is no way to modify the running firewall. The only way to modify the running firewall is to reload the current firewall configuration, which is in etcpf.conf. You also will need to enable PF. You usually do that in etcrc.conf, which is the current location where you would modify what system services would be enabled on your BSD computer. It's equivalent to your etc init.d on older Linux distributions, or your systemd services directory, where you're linking in your active services. Some important commands that we talked about that you want to know about are pfcdl-f, which is the command that you use to load the firewall config. And let me emphasize again, this is the only way to change the running config. If you change anything in etcpf.conf and you do not call pfcdl-f on the file, you will not change the firewall rules. The only other thing you can really do with the pfcdl is get usage statistics. For example, -sa will give you all of the usage statistics for the running set of rules since the last reload. The one other thing that you might need to know is KLD load is used to load kernel modules. On some versions of BSD, I think OpenBSD may be in this boat, you may have to load the kernel module before you can actually get PF to do anything for you. So if you have to load it manually, that is the command to do so. So now let's actually get into some examples. So we'll start with IPTables. So this is how you would set it up. I've based this mostly off the PF firewall, and all of the syntax that you're seeing is written in bash. So the first command flushes the flushes all of the chains. So in other words, remove all of the rules from the chains, and then the X says delete chains that are empty. So that will leave you with only the default chains. The next command allows you to skip traffic coming in on the local loopback interface. The reason why you want to do that here is because loopback traffic is almost always needed and is expected to not be blocked or firewalled. So unless you're in a really secure environment where you really care about what traffic goes over the local loopback interface, you should generally allow that. The external interface binary, this is based off the IPTools command. So what this will allow you to do is figure out what the default path is. Actually have a better command that I can put in there later, but that is an example. The last thing that you'll see there is a variable that we're going to be using to block some addresses that shouldn't be routable from the external side of our network. The other thing you're going to want to do is you're going to want to block some bad packets and put in a default deny policies. So what this command says here is IPTables-P is for policy, and you're setting the policy for the input chain, and you want it to be a drop policy. Pretty simple, straightforward. IPv6, there is a separate command for controlling IPv6 traffic. There's a separate command for controlling IPv6 traffic for IP tables, and this is that command, IP6 tables. So in this one, we're just dropping all traffic and leaving it at that. Going back again, because if we're not going to be using it, we don't need to be allowing the traffic in. So here what we're doing is we're creating a new chain, which we're going to be using to log information about connections going to our machine, and then dropping those connections after we've logged them. So what this second command does is it loads a module called log, and then we set our log level to info, and then log every time we have 5 or more connections every 10 minutes, or 5 or more connections per minute coming from the same source, limiting it to a burst of 10 messages. If you want to see where these messages show up, they will show up wherever the kernel log shows up. That means if you're using syslog, they're going to be showing up in var log messages. If you're using journal CDL, they should show up in your journal CDL. And then the last command is restoring a default drop on that chain. Only the 3 default chains, the input, output, and forward chains, can have policies set on them. So that's why we just use the JAST-J drop here in order to drop them. This would be an example of how to block some passages. So by default, IPTables is a stateless firewall, but it also allows you to do stateful tracking via the contract module, which you can import via the -m contract statement. Then you can also specify the state of the packet. So for example, we're dropping all invalid packets, and then we're also going to be dropping all packets that don't have a valid RP filter. So these next 2 commands is for all of those unroutable addresses we talked about earlier. We're going to reject those traffic if they're going to our SSH or our HTTP server. Any questions on the format here? Okay, hearing none. We can also add exceptions for applications. So here's how we let our traffic back into our stateful firewall. Is this contract state established related? This will force IPTables to check the connections database in order to see whether or not people have connected in the past. And if they're connected, or if it's related to a previous connection, it'll let the traffic in. Likewise, we're going to allow SSH traffic coming in except for when they're making more than 10 connections a minute, or 10 connections, or more than 5 a minute. And then lastly, we're restoring the default policy just in case anything slips through to make sure that we end up dropping invalid traffic. So any questions on the IPTables firewall rules that we used before we move on to Firewall D? Okay. So here's an example of a zone file. Chances are you're never going to edit this directly. This is mostly here for illustrative purposes. So key things to note: you have a description, a short description, the interface name, and then all of these services and rules that you may have associated with a particular zone. So the interface names, you may notice that we have something that doesn't look like F0 as the interface name. This is because we're using Firewall D will mostly show up on computers that are using newer versions of UDEV. And because they're using newer versions of UDEV, they'll have the newer UDEV naming conventions. Notice that we can specify things like HTTPS traffic as simply as saying service name HTTPS. On to services. Here's an example of a service file for the service foo. You may notice that there's a tag called module. Some services will have kernel modules associated with them. One example of this would be FTP. FTP does some really dirty things when it connects and jumps around to a whole bunch of random ports. So it makes it really hard for even a stateful firewall to block and track appropriately. That's why there's an external module to help track FTP connections. As a result, we have the kernel module to help us do this. Not all service files need a kernel module to do it. Their job effectively, just certain ones, for example, FTP. So all of those pages that we just talked about with IPTables becomes this in Firewall D. Notice how it's practically nothing. And we get all of the benefits that we would have had otherwise. Really short, rather convenient configuration. Now we're on to PF. I pretty much blatantly ripped this out of the BSD Now tutorial on PF. I will point out a couple things though. Basically what I've added is a couple of annotations. The external interface in BSD, the default Ethernet interface is EM0 instead of F0, or the EMP stuff from the newer versions of UDEV. Also notice that this is not a bash file. This is an actual PF syntax file. So what we're doing is setting the default block policy to dropping packets, and then we're going to skip the local loopback interface. What we're doing here with matching bad packets in the default deny. So this match in all scrub. So that means when a packet comes in, we want to apply the scrub command to it. So the no df max message 1440 says packets that don't pass the df rule will not be allowed. And furthermore, if they try and send more than 1,440, it will not allow that traffic in. The other thing that we want to note about PF is, by default, you're going to have a lot of, by default, a lot of the traffic will be delayed. By default, traffic will be allowed until it's blocked. Excuse me. By default, the last matching rule wins. So blocking all in is the same as having the -J drop at the end of an IPTables rule set. So the next one is the equivalent of our contract related established. So we're saying let in all traffic quickly on the external interface going over IPv4 and keep state. The quick command overrides that default behavior of BSD PF firewall and drops traffic instead of allowing it. The anti-spoof command, what that will do is we'll try a couple different things, like for example, routing back to the host. If it can't find a valid route back to the host, it will block the traffic. So this will help you determine things like spoofed IP addresses and so on and so forth. So anything that's spoofed will automatically get dropped as a result of that command. As far as I'm aware, there's nothing similar to it in IPTables. So that's one of the powerful things that PF offers you. This is how you disable IPv6 in PF. Notice that PF is a unified solution for both IPv4 and IPv6, as is Firewall D. This also will block in certain packets that cannot be routed back to the host. And then furthermore, blocking any packets that blocking in any packets that came in on or that are going out on the external interface that go to the in that non-routable addresses that we discussed earlier when we went over the IPv4 or the IPTables stuff. So PF has the concept of tables, but they're kind of different than the IPTables version of tables. So these tables are basically flat files that contain addresses that should be blocked. So here he sets up two files. One will block Chinese traffic, which is the second one, and one which will eventually be used to block misbehaving people connecting to our device. We're also logging these. Just like the log command in IPTables, these will go to the kernel log. So if you want to find out what traffic is being blocked, you'll go to the same place with the kernel log, which will be var log messages. Here's how we add the exceptions for our applications, which are 80 HTTP traffic. We can also allow traffic to other ports, in this case 137, 139, 445, and 138 from a specific host, as well as allowing in SSH traffic, as long as we have no more than 5 connections from a given source, and they don't try to connect more than 5 connections every 5 minutes. People that fail to abide by those rules get added to the children, where they will then be blocked by the firewall rule that we had on the previous slide right here. The last statement allows IPMC traffic to enter in, as long as it's and specifically pings, which is the echo REQ, which is the name of that IMPC. So in summary, know your firewall to secure your device, and open source firewalls can be powerful and easy to implement. Here are used in the preparation for this presentation in case you want to look at some more detailed reference material and any questions on the presentation as a whole. You see that we have about 20 minutes left over, so we have plenty of time for questions. So it really depends on what you're using it for. If you're doing anything with a router or anything where you have to forward traffic like a router, PF just beats the socks off of all of the rest of them. If you're on a system that has it, Firewall D is awesome because it's a lot easier to configure, and you'll spend a significantly smaller amount of time configuring it. But that said, IPTables is still better than Windows Firewall. I think I'm getting your voice in from the Skype. I don't know if it is also getting routed back into the Hangout. So I should probably restate the questions that I hear from you guys for future state. Okay. So in terms of features, there's a pretty even amount of feature parity amongst them. The one exception to that would be PF just blows the socks off of anything else in terms of serving as a router. So in a competition environment, if you have a BSD machine that you can use as your router, PF is probably what you want to use. Outside of that, it really doesn't matter in terms of how much work it's going to take in order to do it effectively. Any questions on like syntax or examples, how to use these things practically? Okay. Yeah. And mm-hmm. So okay. So I guess we'll go ahead and call that an evening, I guess. Thanks everybody for coming out. Appreciate any feedback that you may have. I'll probably be hanging out in Clemson's IRC for a little bit longer. But that's about it. Have a good evening.